Hello, my name is Ivan. Welcome to my channel. So this video is part of an assignment of an operating systems project that I have in hand. I'm taking an operating system course, and the problem at hand was that we had to simulate a collision avoidance system. The purpose of the system is to avoid, as the name implies, two cars to collide with one another. So, for the problem at hand, what we have, as I said, the purpose of the system is to avoid one car to collide with the car that's in front of it. So the system has two things. It has a laser device which can determine what's the distance between one car and the other. But the problem is, as you may know, streets are not perfectly leveled. Cars sometimes bump when they go in the streets because there are so many irregularities. And the second part of the system is a gyroscope. This gyroscope tells you what the inclination of the car is respect to the horizontal axis. So with these two tools, with this data at hand, you have to determine what the real distance is from one car and the other. So the real problem, the way it is simulated, is that we have this script which is written in C, which just takes data and loads it into memory. So you basically have to go to that space in memory and read that data. And the difficult part, the part in which you have to think, the part that you have to design and implement, is what can you do to process as much data as you can, to perform as many operations as you can in the most efficient way. And by efficient I mean so that you use the processor efficiently, so that you use so that you don't use too much memory of your computer, of your system, and so that you can execute as much operations as you can in the least time. So the solution I designed, it's comprised of two main parts. I use threads, not processes, threads, and I use circular buffers. In theory, you can take advantage of your process. As you know, most of modern processors they are designed so that you can execute as many threads as possible. Mine is a Core i3 second generation, so I believe I can execute as much as 4 threads, I believe. And in my solution, what it does is that it creates three threads. In this case, 3, because that was for testing. 3 threads, so that each one of these threads can do as many operations as possible. Now, the second part, as I said, is circular buffers. Now, circular buffers are very important because in C we don't have any kind, or we could not use, that was one of the conditions for solving this problem, that you could not use any kind of magic libraries, and you had to work with whatever you had at hand. So if you work with an array, after some time you would run out of memory, because the sensor, the throughput that the sensor has, it is very high. It's very, very, very high. So you're gonna run out of memory in no time. So my solution is using a circular buffer. Should I say 2 circular buffers? One buffer for storing distances and the other for storing angles. And first, I would use 2 indexes. One index for the thread that's going to write the data into the buffers, and one index that all the other threads are going to use to read from these buffers. Now, how does all this work? We have the main process. We're going to call it the parent process. It's going to read from memory. As I said before, all this data, the distances and the angles, they are stored in memory. So you have to retrieve the data from memory, and the main process will retrieve this data, store it in the buffers. And well, in the case of this image, I only have one thread. The point is that you actually use more than one thread, so that each thread can read from these buffers. Each thread has to take a value of distance, a value of angle, and then do the operation to determine what the real distance is. And for this, I use logs, specifically mutex logs, so that we can protect the critical section. And this is something I'm going to talk about now. Why use threads instead of processes? Well, the advantage here is that threads, they share the same address space of the parent process. This means that they not only share memory, they share variables, they share structures. So this way, my solution can be as memory efficient as possible. And not only because of that, but I'm giving as much work to the CPU as I can give based on how many threads it can physically manage. Then again, threads, because they share the same address space, the communication between them is easier. The inter-process communication is easier. The only problem here was the critical section, as I just said, because they both have access to the same buffers. You can have as much threads not as much as you want, but as much as your process allows you to execute in parallel. In this case, I'm gonna have 3, as I've been saying this whole time. So the good thing is that none of them actually write into the buffer. The only one who writes into the buffer is the parent process. But we have to control. We have to control when they read, so that the data they read is not repeated. So in the spirit of showing that this actually works, we're gonna see a little demo. We're gonna see that this actually has no any kind of errors or bugs. So we're going to execute the sensor, and we're going to execute the reader. I have already compiled it, and as we can see, there's no kind of magic behind it. The only problem is that it is reading and doing operations at the speed of light. So at a simple glance, we just cannot see what it's doing. We can see that it is fetching an angle, a distance value, and it is doing the operations. So we're gonna check quickly, more or less, what it did. As I said, I used circular buffers. Here I'm using 2 buffers, as I said previously. The one for the distances and one for the angles. The mutex log, very important, because we have to. The threads must take turns when they are going to fetch the data. That's something very important, because they take turns to fetch the data, not to do the operation. Once they fetch the data, the mutex log is freed, so that another available thread, can fetch data again and do another operation. We also use a thread pool. I believe we have a constant here. Yes. Here we can define the number of threads we're going to use. In this case, I'm using 4 threads. And well, this is just a struct and some functions I've defined to create a thread pool. As I said before, we cannot use any kind of magic libraries whatsoever. And well, some other functions I use to calculate time. We're going to see in a minute why I use this function to calculate the distance. And here's where the magic happens. Nothing out of this world, as I said before. We just read from the buffer the angle, the distance, and do the operation. We calculate the distance. Plain easy. The only thing that we must account for is that we have these two indexes, the one that the parent process uses to write the data and the one that the threads use to read the data. The reader index must always be behind the writer index, so that they do not take repeated data, they do not take old data. And something that what actually allows this to work is the fact that we are not taking any time in taking the data out of the buffer. We simply overwrite the old data and read it and do the calculus, and that's it. How can we check that a threaded reader, as I'm going to call it from now on, actually is efficient, it actually works? So I run some tests. I established a threshold of how many operations each solution could execute and how much time it took. So at 1.5 million operations, we can see that we have a difference of almost 1 second. If we wrap it up and increase the number of operations to 2 million operations, we can see that the difference is of almost 2 seconds, and we can start to see a pattern. If we increase the threshold to 3 million operations, we're going to see the difference is of almost of around 3 seconds. And if we jump up to 5 million operations, we can see that we have a difference of 6 seconds. So with this, I hope we can validate that our threaded reader is valid and is an efficient solution. So that was all for this video. If you have any kind of questions or suggestions about my solution, you can leave it in the comments below. So thanks.